Okay, looks like we've got a quadratic again and we're trying to find the turning point. So, a bit like the first one, except, it looks a bit different. You got that 2 in front of the x squared.
Yeah, that's right. We've got to get the turning point form. That'll make it easy to graph, but we've got that 2 in front of the x squared, so we're going to get 2x squared plus 2x.
Okay, so that's the same thing as 2x squared plus 4x, but you brought the 2 out the front to give you that x squared plus 2x form. So now, just like question 1, it's a matter of factorising that. So, how do we do that?
Well, to factorise that, you just go 2x something all squared to give us back to x squared plus 2x.
Okay, so x plus something all squared to make x squared plus 2x. So I guess that's x plus 1 all squared.
Yeah, x plus 1. And then if we expand that bracket, we'll get x squared plus 2x plus 1.
So got to get rid of that plus 1.
That's right, so we're chucking a minus 1 there.
Great, is that it? Although you've got that minus 7 still from the original quadratic.
That's right, to get back to our original equation, we just need to put a minus 7 on the end.
Okay, that's kind of good. Looks pretty messy.
Yeah, let's clean it up. We'll put a y equals, make it an equation. We'll expand the brackets there, so we'll get 2x plus 1 all squared. Minus 2 minus 7 is minus 9.
Why minus 2 minus 7?
When you expand the brackets from the 2 to the negative 1, you're going to get negative 2, and negative 2 minus 7 is negative 9.
Okay, so now we're good. Now we can plot the graph of that quadratic and turning point form.
Yeah, that's in turning point form, so we just look for our h and k from the first question, and that's the plus 1 there and the minus 9, and that's going to put our turning point down here at minus 9 minus 1.
Okay, that's a turning point. So I guess we kind of just need to get a bit of shape into the quadratic graph, so maybe find the y-intercept.
Yeah, y-intercept's the easiest one to find to start with, so to find the y-intercept, make x equals 0. So we're going to get y equals 2, 0 plus 1 all squared minus 9.
Okay, so that's what 2 minus 9 is y equals minus 7?
Yeah, really easy. Y equals minus 7, we put that on our graph over here at minus 7.
Alright, so we can already kind of see what the graph's going to look like, can't we?
Yeah, we know it's a parabola, we know it's got a turning point at negative 9 down here on the y, and it goes through the y-axis at negative 7, so it'll look something like that, except that goes through negative 7.
Okay, you just fixed it. Perfect. Alright, so we just need to get the rest of the intercepts, the x-intercepts, I guess.
Yeah, the x-intercepts, they're a bit harder because we're going to have to solve a quadratic to find them, but we'll start off over here and see how we go. So we put y equals 0, get y equals 2x plus 1 all squared minus 9.
Alright, so we're solving that for x.
Yeah, we do a little bit of rearranging. We put the negative 9 on the other side, and then we divide by 2, so we're going to get 9 over 2 equals x plus 1 all squared.
Okay, so I guess we get rid of the squared.
Yeah, take the square root on the other side, so we're going to get root 9 over 2 equals x plus 1.
Okay, almost there.
Almost there. Our last step is just to find x, so we go x, it's got a plus 1, just minus 1 onto the other side, so square root of 9 over 2 minus 1.
That's it, that's our x-intercept. Well, that's only one x-intercept.
Oh, correct, because remember when you do a square root, you're going to have a plus minus, yeah? So it's going to be negative 1 plus minus square root of 9 over 2.
Alright, so just got to label that on our x-axis.
Yep, we're going to put that on our x-axis, so the negative 1 plus the square root of 9 over 2 is going to obviously be on the right-hand side, so we're going to get negative 1 plus square root 9 over 2, and that's our right x-intercept, and our left x-intercept is going to be negative 1 minus square root of 9 over 2.
That's it, so we've labelled turning point, we've labelled intercepts, job done?
Job done.